This is a problem from section 3.8, problem number 3. It says here that we have a roast turkey taken out of the oven when the temperature has reached 185 degrees Fahrenheit. It's placed on a table and in the room temperature is 75 degrees. If the temperature of the turkey is 150 degrees after half an hour, what's the temperature after 65 minutes? So we need to use Newton's law of cooling formula. That's the dt, the temperature over d time, is equal to K times the temperature of the turkey at any time t minus T sub s, which is the temperature of the room. And so the room has a temperature of 75 degrees Fahrenheit. And so the first thing that they ask for is the temperature of the room. So we have our formula, dk dt is going to be equal to K times T minus 75. So using the equation, we determined that this is going to be our cooling. We're going to let y equal to T minus 75, and so we have T minus 75 here. When T is equal to 0, let's put T is equal to 0 here. Then the temperature of the turkey is removed, y of 0. So when T is equal to 0, we have 75. T of 0. Oh, that's when the turkey came out. So the turkey comes out, the temperature of the turkey after, let's get it from here. The temperature of the turkey has reached 185 degrees, so that's what we want to put here. And so 185 minus 75 is going to be 110. So now y is a solution to initial value problem of this when so we essentially shifted our temperature problem so that it looks like our differential equation that we've seen before. So the only solution to this differential equation is going to be this thing, and then we'll do the translation back. So using this information, we have y of t is equal to y of 0 times e to the kt, where y of 0 is equal to 110. So now we're given that t is equal to 30, so we are going to be interested in solving for y of 30, because we'll use that information to solve for k. So y of 30 is going to be t of 30 minus 75. So the temperature of the turkey in 30 minutes, that's half an hour. So the temperature of the turkey in 30 minutes is 150 degrees. So this is 150. And so 150 minus 75, I think it's 75. And so now we have those pieces of information. Using this and the fact that y of 30 is equal to 75, we can solve for this. Y of 30 can get replaced with 75. And 100 e to the k times t, that's 30 minutes. So we can put 30 in here. And so to solve for this, we solve for k. So we divide by 75 divided by 110, and then we'll take the ln of both sides. We better do this carefully here. We have 75 is going to equal to 110 times e to the k times 30. So let's just put 30k here. And we're solving for this. And so the first thing we can do is we can divide both sides by 110. So this 110 is gone. And then next we'll take the ln of both sides. So we'll take this thing, we'll take the ln of that, and then we'll take the ln of this, which will simplify. The ln of this makes the 30k go on front, and the ln of e is equal to 1. So this whole thing is just going to be 30k. And then we'll divide by 30 so that k is going to be 30 divided by this thing. So, oh, that's 1 over 30. So 1 divided by 30 times the ln of... Now, this is probably where you might be interested in simplifying. I'm not going to simplify, and let's see if this program will take my answer without it being simplified. So it looks like it worked, and if you were to simplify, you get, 15 over 22. Okay, substituting the value k above, we have y of t is going to be equal to this whole thing over here. And now we have to substitute k is equal to 65. So we're going to need to put 65 in for t. So 65 in for t here and 65 in for t here. That's t's popping up as a 1 over 30 times t times ln of 15 over 22. So there's a lot of stuff going on here. But it's just a matter of putting it into our calculators. And as long as we're being careful putting it into our calculators, I think would be okay. All right, so this is going to be a long one. I'll start off with 110 and then times e, so that's the exponential number, e raised to, again, my caret goes up, but just to be safe, you want to put some parentheses around. 1 divided by 30, and then times 65, and then times the ln of 15 divided by 22. So close the ln, close the thing that the ln is in, and then I think that's all the parentheses I need. I'll go ahead and press enter. And so we got approximately 47.9, and they want us to round off to the nearest whole number, so that's going to be 48. So y of 65 is equal to 48, and we want to translate that back into t's, and so t is going to be y of 65 plus 75. So we'll take our 48 and then we'll add 75 to it, and we get 123 degrees Fahrenheit for the turkey after 65 minutes. So let's see if that kind of makes sense. It starts off with 185 minutes. In half an hour, it's 150. I'm sorry. We'll start off at 185 degrees, and in half an hour, it becomes 150 degrees. So it's going down. And 65 minutes, that's a little bit over an hour. It goes down to 123. Okay. So that part is, did we do it? Looks like it didn't take, so let's try it again. This is 48, and then 48 plus 75, 1, 2, 3. Okay, so now the last part is when's the turkey going to be cooled to 120 degrees so that people can eat it? And so 120 degrees, it looks like they're solving for t, and t is in here somewhere. T is over there, and so they start off by isolating this e, and then they're going to take the ln of both sides, I would assume. And so first thing we want to do is we want to take 120, and then we want to subtract out 75, and then after that we want to divide by 110. And then, let's see, fraction, integer, or exact decimal. So this decimal goes on pretty long, so maybe the fraction, we got 45 over 112. Maybe we'll use that one. 45 divided by 112. All right, that didn't work. Let's try it again. So it looks like we're actually dividing by 110, which is probably the mistake that I had over here. Let's see if we can go back to this. and then we'll divide by 110 instead of 112, and then this is it. So let's try submitting that. Okay, so that looks a little bit better. They reduced to 9/22. And then now to solve for this, so they rewrote this thing. So it looks like they just took the ln of both sides. So that's the ln of 9/22. And then they're going to multiply by 30 on both sides. And then they're going to divide out by this whole thing, the ln of 15/22. And then they want us to figure that out by putting it into a calculator. So we have a 30 times the ln of 9 divided by 22. And then we want to divide that whole thing by the ln of 15 divided by 22. And then we got 70 minutes. So that's close to 65 minutes, another 5 minutes after that. We get 70 minutes for it to cool down to 120 degrees. Okay, so I hope that helps.